Fourier transform of impulse signal, which is a del of t. So x of t is given as del of t. This impulse signal is present at t is equal to 0. T is equal to here the variable is t. So the impulse signal is present only at t is equal to 0. So we want to find the Fourier transform of delta signal, impulse signal. Just apply into the formula. My integral minus to plus infinity del of t e power j 2 pi f t into dt. So using shifting property of impulse function, using shifting property of impulse function, this impulse function is located at t is equal to 0. T is equal to 0. To solve this integration, replace t is equal to 0. So the impulse function is present at t is equal to 0. So in this integration, just to put t is equal to 0. T is equal to 0. So this is the result e power j 2 pi f. Just to put t is equal to 0, the result is 1. So e power 0 result is 1. So this property is called a shifting property of impulse function. To solve this integration, the impulse function is present at t is equal to 0. So replace in the other function, replace t is equal to 0. That is the result. So therefore we arrive Fourier transform of impulse function is equal to 1. So this is impulse function in time domain, whose Fourier transform is a constant. Its value is 1. So throughout all the frequency range, it has a constant value as 1. So this is a frequency spectrum of impulse function. Now, so using this concept, now the second question is Fourier transform of DC signal. So I have the DC signal whose value is 1. So throughout the entire time, the value is 1. So using the property called duality property, x of t having Fourier transform capital X of f, whatever function we have, that function you place it here, replace f by t, whose Fourier transform is whatever function we have here, that function replace t by minus f. In the same, using this property del of t whose Fourier transform is 1. X of t Fourier transform is x of s. So del of t Fourier transform is 1. So this capital X of f brought to here, this one brought to here. This x of capital X of t whose Fourier transform is whatever function we have, the same function brought. So we have the del of t. So del t replaces minus f. So t replaces minus f. So both are same. That is del of minus f and the del of f both are same. So therefore we can arrive Fourier transform of constant DC signal is impulse function in frequency domain. So therefore the time domain, it has a constant value whose magnitude is 1. The corresponding Fourier transform is impulse function located at 0. Impulse function located at frequency f is equal to 0. So therefore again Fourier transform of constant signal is equal to del of f.